In this video, we're going to take a look at how to graph one period of a cotangent function. So similar to what we've done in other videos, let's go ahead and start by kind of analyzing what I have. This time I noticed there's a number being added or subtracted, in this case added, to my function, and what that's going to do is move everything up 3. So in the past, we've talked about moving the midline up 3. We can kind of sort of think of it the same way with that middle center line moving up 3. My a value is the number in front, so I'm going to note that the a value is 1 this time, which is not an amplitude, but it will have an effect on my graph. And then my b value is 1/2, which will affect the period. So let's go ahead and figure out what the period of this cotangent graph is. Just like with tangent, to find the period, it's the normal period, which is pi, divided by our b value, which is 1/2. So I have 1 pi divided by 1/2. Either use a calculator or just remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So no matter how I think about it, the period of this graph is going to come out to be 2 pi. So let's go ahead and take this information now to make a sketch of one period of the cotangent function. Unlike tangent, the cotangent function is located, again, just to the right of that y-axis, so I don't need to worry about this space over here. There'll be other periods of the graph over there, but that's not what I'm going to graph now. So I don't even need to worry about splitting the period in half, again, like we did with cotangent, or with tangent. My period goes from 0 to 2 pi this time, and since we're all to the right of the y-axis, I do what we've done with sine and cosine, okay? Those two spots, though, there'll be something special there, unlike sine and cosine graphs. I'll have asymptotes at those locations, so at 0 and at 2 pi, sort of like goalposts to keep my my cotangent wave in between there, okay? I guess also similarly to what we've done with cosine and sine graphs, I'm going to need the halfway point, which would be 1 pi, and I'll need half of the halfway point and then the 3/4 point as well. So we can find these. We're just going to divide our scale up into 4, or I've shown you in the sine videos how to find these values using some multiplication tricks. No matter what you need to do, though, to find these, that point should be labeled pi over 2. And this point should be labeled 3 pi over 2. And yes, I want to see every single one of those on your graph. Okay? To get your y-axis scale, well, I'm going to remember that I've already started by moving that graph up 3 spaces. So first thing I'm going to do is note with 3 tick marks, 1, 2, 3, that's where my graph has been moved up. So it's up to you if you want to draw this dashed line in or not. I like to draw it in just because it helps remind me where the graph is sort of centered. But that's not an asymptote. It's nothing. It's just kind of where the midline has been moved up to. And then from there, using that a value, I need to count up 1 space. So I'll put a tick mark at 4. It's not an amplitude, but it is a significant point. And I'll need to count down 1, which would put me at 2. Again, not a low point, but it is a significant point. All right, using all this information, I can now get a sketch of what my cotangent function looks like. Notice this one, too, has not been reflected since the a value, or that's not the a value. Since the a value is positive, this graph has not been reflected, so it'll follow the normal curve of a cotangent wave. All right, so let's go to my center point, 1 pi. Normally I'd put my point on the origin, or on the x-axis, but this time, since we've moved up 3, that center point is going to be right there. If I counted forwards to 3 pi over 2, the normal curve of a cotangent wave was kind of like that shape. So the normal, non-reflected, is going to be at 3 pi over 2 and then up 2. If I counted just pi over 2, that point's going to be at 4. So that was the significance of the 2 and the 4. And now we kind of have something that looks similar to a tangent wave, maybe a reflected tangent wave. But just like we did with those, I'm going to start close to the asymptote. I'm going to curve through those points there, and then end by, again, curving towards the asymptote, getting close to it, but never quite touching that asymptote. And there is one period of my cotangent function.